Good morning, everyone. My name is Rahul Bhatia. Today, I will be presenting my paper on digital finance meets Internet of Things, where we will design event-driven architecture with fog and cloud integration. The Internet of Things technologies and digital finance mix are changing the way financial processes are now performed and oversight and streamlined. The financial systems that we are working on a day-to-day basis require high throughput, low latency systems, which are basically capable of handling large volumes of data on a day-to-day basis. Every event that we perform is depending on a transaction or basically a process. In this regard, that traditional centralized architectures are currently falling short of such demands, which result in bottlenecks in operations and performing decision-making processes. In this research paper, we basically focus on a distributed and event-driven architectural framework, which is proposed for efficiency processing, such as Internet of Things, which are triggered by financial events, which integrate with fog computing, event mesh technologies, and SAP Business Technology Platform, which is referred to as SAP BTP. This model, which helps us to bring conceptual or computable resources closer to Internet of Things devices with the support of fog nodes, enabling high demand validation, filtering, and reaction to various events. This allows SAP BTP to be utilized for enterprise integration, advanced analytics, which is driven by SAP SAC Analytics Cloud, and also executing business logic in the system. The architecture, which is based on event mesh processes, consists of operational influences, various workflows, and regulatory requirements. Along with these developments, it is important to note that decentralized computing is therefore focusing on not only just traditional architecture's ability to manage large volume of data, but also speed of the business events which are triggered by the Internet of Things. Centralized processes, which introduces latency, bottlenecks, and also a single point of failure, especially in financial settings or mission critical applications, are very critical in where we need to automate the decision making and also ensure that scalable communication is distributed across various environments. The combination of Internet of Things and digital finance basically is one of the main challenges in the way financial operations are nowadays performed, observed, and improved. The connected real-time generated data by billions of devices in the ecosystem is increasingly shaping financial systems, necessitating real-time alerts and actions. Alongside these developments in the centralized cloud computing, there is growing challenge in the traditional architecture's ability to manage the volume and speed of business events triggered by the Internet of Things. Fog computing is one such distributed architectural distribution system. Fog computing allows the processes to be addressed with these limitations. Fog computing is the decentralized approach that places processing closer to Internet of Things and also reducing latency and improving responsiveness to the architectural processes. The critical problem, however, still remains the same. Basically, it is how to integrate the unified scalable frameworks that match enterprise needs. The combined aspect of managing distributed processing involving various heterogeneous Internet of Devices, fog nodes, and cloud environments demand advanced architectural models. So, as you can see, the fog computing requires the Internet of Devices, fog nodes, and cloud environment to basically have a responsive behavior towards the architectural distributed computing systems. Fog computing has become a potential complement to traditional cloud systems where the event takes place and the response is at the same time. It does not take for the response to be analyzed and then a response should be given. Fog computing, on the other hand, provides a distributed processing capacity to the network's edge. The distributed technique minimizes the distance of data transmission, providing faster processing and a direct response to local events. Fog computing has proven invaluable in reducing latency and enhancing system performance in various industries, including manufacturing, smart cities, and nevertheless, it is relatively unknown how it can be used in financial infrastructures, especially in the processes which are utilizing the Internet of Things. There is flexibility that can be achieved by building applications that respond dynamically to discrete events, enabling them to react in real time for inputs. Event Mesh is such technology that allows and complements such architectures to ensure distributed applications and services can be connected through reliable, scalable, and event forwarding. The event-driven model that has proven successful in many industries such as e-commerce and logistics, however, is application to financial Internet of Things environment, which creates special requirements, including high security demands and compliance with regulations. So in this research, we have proposed architecture that basically focuses on fog nodes, primarily basically on filtering and also responsive actions based which are driven by event meshed processes. The Internet of Devices, whether it's mobile, laptop, or any other system, generate event messages that speak with the fog nodes, which basically further processes these messages and also provide responsive actions. There is real-time routing, which basically ensures that governance and security is in place with real-time encryption and authorization workflows that trigger SAP BTP cloud layer. In this cloud layer, we have a business logic, a business requirement that helps us basically display the data via SAP Analytics Cloud, and also with taking care in mind that compliance is must and it must be taken care of upfront in the process. This all is based on event mesh technology, where we can filter a event and then basically allow different devices to react to that event. Thank you.